Okay, so let's look at some examples. So we're supposed to identify the input values where the slope of the function is 0 or reaches a relative max or minimum value. All right, so for let's just do each of these first, kind of on as we go down. So 3, the function is 0. Well, it's no zero slope. Zero slope is going to be if we have a peak or a trough. It'll be the zero slope there. So there's no zero slope. Okay. What about here? Well, there we'll have a zero slope at and probably about b. So then we could say the zero slope is x equals b. Okay. And then what about this one? There's no zero slope again. And here again, there's no zero slope. Okay. So I think that answers those questions there. So now let's go into the next part, which is going to ask, indicate the input intervals over which the slope of the function has the following characteristics: positive, negative, increasing, decreasing, and constant. Okay. Excuse me. All right, so for 3, what do we see? Well, it's basically going to be positive the whole way, because it's positive, positive, positive. So the whole interval is going to be positive. Okay. Now here, we're going to be positive up to that point, and then we're going to be negative. Okay. And then we're going to have basically the part where it's kind of a uh, that zero, it's not decreasing or increasing. So from I don't know what we'd call this. Let's say let's just call it x less than b is increasing positive slope, and x greater than b is a negative slope. Okay. Let's see. Now, I guess we didn't indicate increasing and decreasing. So this one, it's increasing on the whole, basically, interval. Its whole interval is positive and increasing. This one, it's increasing and then it's kind of getting uh, lower. And so let's say x, oh, how about less than a? And then here it's going to be increasing so it's going to be increasing up to that point, and it's going to be, okay, so let's just write that x is increasing slope, and then it's decreasing basically from here and here. So let's do that. I think I'm going to run out of room here. Let me put another page in and I'll be back. All right, so I got another page added in, so I can put it on the next one if I need to. And so it's going to be increasing as we get up to this point. And here, this is, zero, close to zero, and then we're getting more negative, but then here we're getting closer to zero again down here. And so I would say then x greater than c is also increasing, because it's increasing, getting closer to zero in that sense. So if you think about, it's here's your negatives, here's your positives, getting closer to here is getting closer, it's increasing, whereas down here it's very negative, so that's not what we'd want. And then what about decreasing? Well, it's decreasing basically from here all the way up to here. So I would say from a less than x less than c, it's decreasing. Okay. All right. So next, let's see. For this one, we're decreasing, or it's a negative slope the whole way. That's the key thing. And what is it doing the whole way? Here's the steepest, and it's getting going like this, and so it's getting closer and closer to zero as the whole way. So it's a negative slope, and it's increasing the whole interval. Okay. Now, what about this one? Well, this one, it's positive slope the whole way. Okay. And on this one, what's it doing? Well, here it's kind of the steepest, and then it's getting closer and closer and closer to zero. So it's a decreasing as well, whole interval. Okay. All right. So I think that has everything there. And now we're supposed to sketch a slope graph of the function. All right. Well, so that would be kind of a g prime and then g, j, and t of x. So let's go over here. And so for 3, we said it was basically positive and increasing over the whole interval. And so if we think about that, that would do something like that. And I think we had some point here, A, and so we'll call that point A. Okay. That's how we'll do that one. And then what was the next one? 4. And so it's going to be going up. That's a 0. And then it's going down. All right. So let's try that. So 4, we're going to have kind of a funky one. So I think we'll have to do something more like this. And so we are close to 0, then going up. That's going to be kind of a peak here. So it's a peak here at A, and then there's going to be, it's going down, and that's going to be the lowest point at C, and then there's going to be a 0 at B. So if we call this B, and say this is A, and this was C, there's going to be some C, we're going to have a lowest point. A, there's going to be some highest point. It's going to go through this point B. And what else did we have? So it's close to 0, increasing to that point, and then the slope goes down. And so we're kind of going up, and then we're going to go down. We're going to go through B, and then it's going to come down through C as the lowest point, and then it's going to kind of keep going up. And if I remember right, it doesn't go past to that. Yeah, so it goes close, but it never reaches the 0, and so that's kind of how that one would look. So we have, our positive max, our negative min goes through the point 0 here, and it's kind of increasing, decreases, increases, but it never comes back to that. All right, so what about 7? Okay, 7, it's decreasing the whole way and negative slope the whole way, and it's increasing basically on the whole interval. So this one, remember, we're in the negative part. So we're down here in the negatives. It's increasing the whole way and getting closer to 0. And I think it had some point A here, and that could be that point. We don't know exactly what it is, but we'll call it that. All right, so what about 8? So 8, what we have is it was positive slope the whole interval, decreasing over the whole interval. All right, so it's positive over the whole interval, so we're positive, and it's decreasing over the whole interval. And again, the actual shape is going to be something similar to that, and I think that was an A as well. Yeah. And so it's something like that. But again, all we know is it's positive up here, it's decreasing over the whole interval. And so that would be kind of our general shape for this curve itself here. Okay. All right, so that's those three, and that's all they had asked for. So now let's go to the next one. And the next one is a phone bill. So it says the figure shows, and here's our figure. Now the key thing is this is our C of x, and they're asking us to draw basically a rate of change. So our C prime of x, and if this is quadratic in nature, which it looks like, that means this one is going to be linear. Okay, so that's kind of a thing we're going to know is this is quadratic, this has to be linear. Okay, so let's see what it says. Draw tangent lines for 2001, 5, and 7. All right, so 98, 99, 2001 would be 3. So, and again, this is all estimates. And maybe I should go back to, let's erase that. Let's do this. And we can draw our lines like this. All right, so we'll need a vertical. That's about there. And we'll need another one. Go down. About there. And so then okay, so let's get our slope off of that one. So now, I guess I should have left that open. So now I'll need another one of these. Maybe we'll put it on 2. I need a horizontal that I can move around. That doesn't look straight. Doesn't look straight either. I guess that's the straightest. So at 4 or 3 there, let's go back to writing here. Pin. That's right. So this one looks like maybe 3 comma, I don't know. Let's call it 47. That's just for this. And so then if we move that down, then we can get this one to be, let's call it 45, 245. And then that gives us our slope for that line. So the slope is going to be 47 minus 45 over 3 minus 2. So that's going to be 2 over 1. So that slope's about 2. And so now we're going to have to do all that again. And so now let's see what was the other one they wanted, 2005. All right, so let's move it to 2005. So that's going to be 5, 6, 7, roughly. I need a longer line. And so that's, I don't know, we'll call that something as soon as we make our new tangent line. Maybe that will work. So that'll be one of the points. And so that point will be 7 comma, we'll call that 51 maybe. And so then let's do the next one. Let's call it, that's almost there. And so then it's going to be, actually, I don't know. That one's not exactly maybe on there. Might not be 751. Let's move that down a little bit. It's probably 51. Now let's go down here maybe further. Get the next one over here so it's not so close. Maybe that's 50.5. So let's write that. And that's for 50.5. So, we're almost at that point where we have a horizontal slope, but I think it's probably higher up, but maybe it is at actually 7. That's one of those things that's hard to say. Um, so let's go back here and see, if we, yeah, I don't think that's the peak. I think the peak's over here closer to 8. So yeah, we'll call that our next slope. And so then if we do that one, we have a slope equal to 51 minus 50.5 over 7 minus 4. So that's equal to 0.5 over 3. And so that's basically what, about 1/6, I think. Yeah, so that's. And then what was our last point? 2007. All right. About there. So that point is going to be about, and maybe we'll call that again close to the 50.5 because that's as good as we're going to get. So it'll be 950.5. And then let's get our next point, and we have to draw our, oops. All right, so that's that one. So let's go maybe there, and then this one will be up here. It's over the limit, so we probably shouldn't do that one. Maybe we can do 10. It's right at the edge there, so we'll say that's that. Could we go that high? No, we won't say that. We'll say it's about 49.8. So 10, 49.8. And so that slope then is equal to 50.5 minus 49.8. And that's all over 9 minus 10. So we get 50.5 minus 49.8 divided by -1. So that's going to be a negative 0.7. All right, so what we have then is if we have, let's see here, we had the points we're going to plot basically. And so we have something, this is going to be maybe a 2, and that's about a 1. We need some negatives, and that's about a -1. So here's about, maybe call that a negative 0.7. We'll call the 0.2 about here, so that's about the 1/6. That's about the 2. And so now we have at the intervals, we have to go all the way to 9. So 1, 2, 3, 4, 5, 10. And so at the 3, 1, 2, 3, we had this. At the 7, that's 3, 4, 5, 6, 7, we had this. And 8, 9, we had roughly that. And if we sort of draw our line in with this It's roughly that. That's kind of what it kind of would look like roughly. If we had a big point there and a big point there, big point there, that would be our line. And again, we got that linear line going down like that. So that's what we should get for, starting with a quadratic, we should get this linear output like this. Again, if we had, a nice graph paper, we could hopefully get a little bit better, but again, drawing our tangents, we're not going to be perfect. So we're just estimating best as we can get on those, and that's what we have as far as our graph there goes. All right. So now we're on to membership. Okay. So with membership, it says the figure. Oh, did we get everything on the last one? We estimate and record the slopes. Okay, I guess the only thing we didn't write properly probably is what do those memberships actually mean? And so let me get my book out so I can read what the actual values are asking for. Let's see, phone bill. So it says that's in dollars per year. And so these are going to be all in dollars per year. Okay, so that was the only thing we didn't put in there. And then, of course, this is going to be X years, and that's our C prime, and that's in dollars per year. Okay, so that was the only things I hadn't got labeled, and we got the sketch graph labeled both axes with units as well as values. Okay, so we got the dollars per year, X years, and we got our dots on it. So that looks good. All right, so next thing, membership. So let's see if we can do this one. Do we have to do X? Yeah, we have to do that again. All right, so here we're going to do the, let's not get that big. All right, so a figure shows membership on a campus organization during its first year. Estimate the average rate of change in a membership from September through May. Estimate the instantaneous rates of change October, December, and April, and then sketch a rate of change graph for memberships and label the axes. All right, so what we need to do is we need to look at it and estimate the average rate of change from September through May. Well, and this is September, October, November, December, January, February, March, April, May. And so this is September, this is May. So what we need to do is find a slope from this point to this point. And so what we will do is we will add in our line. That's about as good as we can get. And so then after that, let's go ahead and figure out some slopes here. Maybe we'll see where 100, oops. That one is, and then we'll do one vertical at that point there, maybe. And then if we move that up a little bit, well, I'm going to call that good enough for how we're doing this anyway. So we have of x is 4, y is 100. And let's look and see if we can find another point. It doesn't really matter. Maybe we'll do 60, and maybe that's 1 1/4. Okay, so that slope is going to be 100 minus 60 over 4 minus 1.25. And so that's going to be, I'll get my calculator out here, and we'll have the 100 minus 60 divided by 4 minus 1.25, and we get a slope of 14.5 roughly. Okay, and it's approximately 14.5. And this is what? Members per month. Okay, so that's going to be our average rate that it was asking for here. Estimate the average rate of change. So this is our AROC. Okay. And so then part B says, estimate the instantaneous rates in October, December, and April. All right, so let's see, September, October, we need this one. November, December, we need that one. January, February, March, April, we need that one. Okay. So in October, let's stop that. That's going to be there roughly. So that's, I would say, is almost exactly the same as this one. So I'm not going to know for sure, but that would be my best guess. So let's go ahead and do all the work here. So 1, and that's going to be what? Is it 100? Probably not. Let's draw another one here. So it's roughly 100. Okay, so if we call that roughly, let's say, where's my pen? We could say that's, going from 1 to 2 is roughly 100 to 115. So it's roughly 15. So let's call in October, let's call it 15. And that's going to be members per month. Now let's see here. December, it's going to be, it looks like it's going to be a negative. So we're going to, let's see, what is April? Where's April? I'm going to call it April almost. It's almost at the, it's not at the 0 up there. All right, so, but it's positive. So let's do the next positive one first, and then we can do the negative next. Maybe we'll use that. And so now where does that put us for this one? What do you call that? Maybe 7170 or 90 rather, sorry. And then we can move it over and maybe we can come to 4. And we can come down. And maybe that's 175. So we can say for 175. And so when we do 190 minus 175 divided by, what do we have? 7 minus 4 is 3. So that's going to be roughly 5. So we can say in April, it's about 5 members per month. And again, these are so much of an estimate. We know we're not probably even any close to what they would actually have if they had the actual curve data and stuff like that. So this is just again close. And so then December, is that an inflection point? I don't know. Might be. I don't think so. It should be over here, I would think. So which way should we be? We should be on the bottom side. Maybe a little bit more. Yeah, it looks better. And so on that one, we're roughly at, oh, let's call that 85. So we'll say 3 and 85. And then we can also move over to say, I don't know, let's go to 5 here. And we can go down. And maybe that's 76 maybe. And so it'd be 576. And so here we take 85 minus 76 over 3 minus 5. And so that gives us a final answer of about 4.5 minus. So about 4.5 negative members per month. And so now hopefully we've got all that. Now what else do we need to do? Sketch a graph of the rate of change for membership, label both axes. Okay, so we've got the points we need. So now let's draw what it should look like. And so we're going to have positive and negatives, so we have to go all the way down. Let's kind of just cut it here in the middle somewhere. Now, I don't know if I want to draw too exact, so what we'll do is we're going to have at this point, we're going to have the horizontal, we'll have a horizontal and a horizontal. And so we kind of see where those are. So that's about what? 1.25 and 3.5 and a little over 7.25. So, you know, what we'll have is about here. I don't know. Yeah, let's call it here, about here, and maybe a little ways down here. Those are all going to be zeros. And then this is positive and it's decreasing. So positive decreasing, that's going to go like this. Now, we're going to have an inflection point about there. So that's roughly kind of in between those two, almost halfway. So it's going to give us a minimum between those two. Now, again, this is just drawing. I'm going to assume it goes back up because I forget to look, but yeah, it's going to go back up. We're going to have an inflection point about halfway between those two, and then it's increasing. So we go up, and it's going to be increasing, and then we're going to have a point where it reaches a max kind of halfway between these two, so about here maybe. And then after that, it was decreasing up to that point where it hit 0, and then it went below. There. So it had that max, and it comes down, decreasing, goes to the 0. Well, we just can't draw here, can we? And then it just keeps decreasing. It sort of look like. So based on what it has, it looks like it just goes down. So we don't know how far. And so that's kind of our graph. We knew those points, and I'm not labeling anything that way. I don't have it off, but this is going to be again, it was, I think, m prime of x, and this is members per month. And this was in months since September, I believe. Okay. And that was our x-axis. Okay. All right, so let's stop there, and then we'll come back with the next one.